The Wubi Zixing input method, literally the 5-brushstroke character model input method, or simply Wubi for short, is a method for typing Chinese characters. Unlike more popular phonetic input methods like Pinyin, which are based on the pronunciation of a character, Wubi is a shape-based input method, meaning the sequence of keys pressed for a desired Chinese character is based on the shape of the character. In being shape-based, Wubi has a steeper learning curve to phonetic input methods, and it might slow you down when you can't remember how to write a character, but it also can be a bit faster than phonetic methods once you get good at it, that is. It lets you type characters you can't pronounce, it forces you to remember how to write the characters you're typing, and it has very few code collisions, meaning very little time is spent picking from a list of options, unlike with phonetic methods where code collisions are unavoidable due to homophones. Once an important skill, Wubi has today been mostly supplanted by phonetic methods like Pinyin, but Wubi is still really interesting to me. It's definitely harder to learn than Pinyin, though not as hard as it might first appear. Not only that, it also feels really rewarding to learn and fun to use, even if I'm not particularly good at it just yet. I've been using it as my main way of typing Chinese for the past few months at this point. In this video, I'll briefly explain how to type with a Wubi input method. Before that, though, I should explain that there are a few distinct editions of Wubi, namely Wubi 86, released in 1986, Wubi 98, and Wubi New Century. All of them work by the same basic principles, with the differences mainly being some adjustments to the keyboard layout and some character codes being tweaked. This video will introduce the 1986 version of Wubi, since it's what I learned, and since it appears to still be the most popular edition. Now, on to typing with Wubi. The first thing to understand about Wubi is the 5 brushstrokes. Wubi considers there to be 5 distinct types of brushstrokes that can make up a character. Stroke 1, horizontals, including rightward rising diagonals. Stroke 2, verticals, including those with hooks. Stroke 3, leftward falling diagonals. Stroke 4, rightward falling diagonals, including dots. And stroke 5, bends. Take a look at this QWERTY keyboard. The 5 types of brushstrokes are each assigned a region on the keyboard as region 1 for horizontals, region 2 for verticals, region 3 for leftward falling diagonals, region 4 for rightward falling diagonals and dots, and region 5 for bends, occupying 25 keys and leaving Z unassigned. Let's take a closer look at one of these keys. This region up here is a list of all the roots assigned to this key. The big root in the top left is called the keyname character. The number is the key's position number. Perhaps this list of roots seems arbitrary to you, but remember the numbers we assign to each of the 5 roots. This key is key 5-2, and stroke 5 represents bends and stroke 2 represents verticals. Of the roots on this key, these roots are placed here because their first stroke is stroke 5, a bend, and their second stroke is stroke 2, a vertical. This leaves a few roots behind. Of those, these 2 are here because they have 2 copies of stroke 5, that is, they're made up of 2 bends. Finally, the ear radical is placed on key 5-2 because one of the roots already on this key looks like an ear. These are, in general, the rationales for placing roots where they are. Roots might be placed on a key for having a first and second stroke that matches the position number of the key, or grouped for stroke reduplication, or grouped for a somewhat arbitrary but usually mnemonical reason. There's one more character in the corner of each key. This is a shortcut character typable with a 1-letter code, but it is not necessarily part of the list of roots. It's here because it's a commonly used word, but it can't be used for building characters unless it's also listed as a root above. The rest of the keys in the chart are also similarly assigned roots and shortcut characters. Now that we have the keyboard layout, which, when typing, you would reference or eventually have memorized, we can talk about how Chinese characters are assigned codes within Wubi. It's important to understand that each given character can have multiple codes. Every character is assigned a full code, 3 or 4 letters long, based on the rules of Wubi. For example, the full code of Wo is TRNT. Abbreviated codes are 2 or 3 letter long codes that aren't already used as the full code of a character, so they are assigned to type some character whose full code starts with the abbreviated code. For example, Wo has an abbreviated code of TRN because TRN isn't already another character's full code. Shortcut codes are 1-letter long codes. There are 25 characters with shortcut codes, each a commonly used character. They're usually based on the character's full code, but are sometimes arbitrarily assigned, and therefore must simply be memorized as part of the chart. 我 is a very commonly used word, so it has the shortcut code of Q despite Q never appearing in its full code. To sum up, all supported characters have a full code. Some characters have abbreviated codes, and 25 characters have shortcut codes. Full codes can be reliably derived from the rules of Wubi. Abbreviated codes are always just the first 2 or 3 letters of a full code. Shortcut codes are arbitrary. The hard part, then, is learning the rules of Wubi to find the full codes, which is what we're going to talk about next. Let's say we have a character in mind that we want to type. First, we must ask what type of character this is. A keyname character, a non-keyname root, or an off-chart character. The simplest is keyname characters. Just press the key it's on 4 times. For example, to type shen, press M, then space. For non-keyname roots, which are any character that is a root found on a key but which isn't the keyname or the shortcut character since it isn't a root, the steps are: identify the character you want to type the key it's on, type its first, second, and last brushstrokes. Remember, the single brushstrokes are also roots, and they're found on the keys G, H, T, Y, N. For example, shi is typed with F for the key it's on, G for its horizontal, and H for its vertical. It only has 2 strokes, so we stop there and find that the full code for shi is F, G, H. Shi is typed with F for the key it's on, G for its first horizontal, H for its vertical, and G for its second horizontal. We find that the full code for shi is F, G, H, G. Yu is also found on the F key, but it has way too many strokes for us to type all of them. Luckily, we only need to type the first 2 strokes of the final stroke, dropping everything in between, so the full code for Yu is F, G, H, Y. There's a special case for single-stroke characters. The first 2 steps are still the same, but instead of stopping after the first stroke, we add 2 L's to make the code 4 letters long. This is how you acquire the full code for E. E can be found on the G key, so we first type a G. Its first stroke is a horizontal, so we type another G. And since it only has 1 stroke, we add 2 L's to get its full code, G, G, L, L. Similarly, E can be found on the N key, so we first type an N. Then, its first stroke is a bend, so we type another N. And since it has only 1 stroke, we add 2 L's to get the full code of N, N, L, L. The last category, which most characters fit in, is off-chart characters. To deduce the full codes of characters not already found on the keyboard chart, we will have to decompose the characters into roots that can be found on the keyboard chart. Each root is assigned a letter, and we type them in order to type the desired character. And to decompose characters into roots, we should keep a few rules in mind to make sure that we get the correct decomposition used by Wubi. Though not explicitly stated as a rule, I feel the need to point this one out. In Wubi, we never sever single brushstrokes. A single brushstroke should never be broken up and used in multiple roots. For example, the vertical trunk of guo is written as a single stroke, so the decomposition on the left is invalid, because it breaks the vertical in half and shares it between 2 roots. The correct decomposition is the one on the right. Similarly, in shi, the horizontal is written in a single stroke, so when decomposing, the horizontal belongs to either one root or the other, it cannot be shared. The next rule is to follow the writing order, that is, sequence the roots in the order you would write them if writing by hand. This is roughly the same as the top to bottom, left to right, outer to inner rules of stroke order. Writing order isn't exactly the same as stroke order, though. Sometimes a single root is started, then a different root is written, and the first root is only finished afterwards. For the sake of intuitivity, in such cases, we still consider the first root to be a single root. For example, guo is decomposed with the enveloping box remaining in one single piece, despite the fact that we write the final stroke at the very end when writing by hand. The next rule is to choose the intuitive decomposition. Roughly what this means is, when there are multiple possible decompositions, choose the one that's easier to see. In particular, if a character can be analyzed as being one root augmented by a single stroke, then prefer that decomposition over others. For example, Bu can be seen as the bottom part augmented by a single horizontal line on top, so we prefer this decomposition over other possible decompositions. And the next rule is to prioritize larger roots. This means that roots are greedy. While you're building a root, keep trying to take more brushstrokes of the character and see if you can form a bigger root, and keep doing this until you can't anymore. In other words, try to give as many brushstrokes as possible to roots earlier in the decomposition. A consequence of this rule requiring us to maximize the size of roots is that we should minimize the number of roots in our decompositions. For example, Ping is decomposed in the manner shown on the right. The middle decomposition is wrong because it's possible to give the second horizontal to the second root, so giving it to the third root is wrong. The left decomposition is also wrong because even though it minimizes the number of roots, it does so by violating stroke order. The dots are written before the bottom cross, so we can't put the cross before the dots. There are 2 more rules left, but to explain these I have to explain something else, which is the 3 ways that roots can interact with each other. They are separation, where a character is formed by roots that are clearly separable and do not intersect. They may have physical distance that separates them, but it's also okay if the roots touch, as long as they don't cross. Augmentation is where a character is formed by adding a single connected stroke or a single dot which may be disconnected to an existing root. For example, zi and qie are augmentations because a single stroke is added before or after an existing root. Tai and shu are also augmentations because a single dot is added to an existing root. Even though the dots do not touch the roots, this is okay because dots are allowed to not touch. Ya and Dan are not augmentations. They're formed by adding a single stroke to a root, but the single stroke isn't a dot and is disconnected from the root. These characters are therefore actually formed by separation, not augmentation. And intersection is where 2 roots cross brushstrokes, overlapping each other. With that, the final 2 roots, which apply when we have 2 possible decompositions for the same character with the same number of roots, tell us to prefer separation over augmentation and prefer augmentation over intersection. These rules allow us to distinguish characters like Wu and Niu. In Wu, we have these 2 different possible length 2 decompositions. The one on the left requires an intersection, while the one on the right does not. Thus, we should prefer the one on the right. Conversely, in Niu, we have 2 possible decompositions, the same 2 in fact, but both of them require an intersection, and so rules 4 and 5 don't actually apply here. The one on the right, however, maximizes the size of the earlier root, so we should prefer the one on the right. Do note, however, that rules 4 and 5 only apply under the precondition that the possible decompositions we're choosing between are of the same length. If one of the decompositions is shorter than the other, then we should prefer the shorter one even if it violates rules 4 and 5. For example, Pho has these 2 possible decompositions, but the one on the right is the correct one. Even though the one on the right requires an intersection whereas the one on the left does not, the one on the right only takes 2 roots and not 3, so we should prefer it. And with those rules, we should now be able to decompose any character into roots. But once we have the decomposition of a character into roots, how do we get the character's full code? The simplest case is for characters with exactly 4 roots. In such cases, like with Che and Ting, the full code is simply the letters corresponding to each of the roots in order. All codes are at most 4 letters. Some characters, though, might have more than 4 roots, for example, Yi, Han, and Nang. If a character has more than 4 roots, we take only the first, second, third, and last roots, and we type the corresponding letter for each root for the full code and drop everything in between. If a character has only 2 or 3 roots, there's often a problem with code collisions. This is often caused by different roots sharing the same key, leading to characters with different roots ending up with the same code. And so there's something extra we have to do to get the full code. We need to add an extra letter called the Disambiguation code. The first 3 keys in each of the 5 regions are used for typing disambiguation codes. When we have a character with less than 4 roots, we enter one of these disambiguation codes to specify a little bit more information about the character, namely the final stroke of the character and the character model. We specify the final stroke using the numbering scheme from earlier: stroke 1, stroke 2, stroke 3, stroke 4, and stroke 5. The final stroke of the character determines the first digit of the position number of the key we need to press. The second digit of the disambiguation code is determined by the character's model, and each character is considered to be in one of three models. The models are 1. Left-right, 2. Top-bottom, and 3. Miscellaneous, which is everything else that can't be easily categorized as either of the first two, such as overlapping structures or enveloping structures. Note that characters formed by a single stroke augmentation, such as tian, also count as miscellaneous. Even though tian is clearly formed by two roots on top of each other, we still consider it of the miscellaneous model because one of the roots is a single stroke. Let's go through a few examples. Mu and sa, the same code before disambiguation. The last stroke of mu is stroke 4. Mu is in a left-right structure, so model 1. Stroke 4 model 1 gives us y as the disambiguation code, so the full code of mu is ISY. The last stroke of sa is stroke 1. Sa is in a left-right model as well, so model 1. Stroke 1 model 1 gives us g as the disambiguation code, so the full code of sa is ISG. Deng and dai also have the same code before disambiguation. The last stroke of deng is stroke 4. Deng is in a top-bottom structure, so model 2. Stroke 4 model 2 gives us u as the disambiguation code, so the full code of deng is TFFU. The last stroke of dai is stroke 4, but dai is in a left-right structure, so model 1. Stroke 4 model 1 gives us y as the disambiguation code, so the full code of dai is TFFY. One last example, shi and wui have the same code before disambiguation. The last stroke of shi is stroke 4. Shi is in a left-right structure, so model 1. Stroke 4 model 1 gives us y as the disambiguation code, so the full code of shi is JFY. The last stroke of wui is stroke 1. Wui has its roots overlapping. It's neither left-right nor top-bottom, so it's model 3. Stroke 1 model 3 gives us d as the disambiguation code, so the full code of wui is JFD. There are some exceptions where the final stroke used for the disambiguation code differs slightly from what you would expect based on the actual stroke order. In enveloping structures, where there's a clear inner-outer relationship between the roots, the final stroke used for the Wubi disambiguation code is actually the final stroke of the shape on the inside rather than of the whole character. For example, in yuan, the last stroke when writing is this horizontal, but since this is an enveloping structure, we should use the last stroke of the inside shape, being this red dot, or stroke 4, to determine the disambiguation code. Due to differences from person to person in preferred stroke order, if a character's final stroke happens to be the last stroke of any of these shapes, then we consider the last stroke to be the bend in the bottom right, which is stroke 5. For example, in bian, the last stroke when writing is this bottom stroke here, but since this is part of an enveloping structure, we disqualify it. The last stroke of the inner shape is then this blue stroke here, but since this is on our exception list, we actually consider the final stroke to be this red bend, or stroke 5. For characters whose final stroke is the last stroke of these shapes, we consider the final stroke to be the leftward falling diagonal, or stroke 3. For example, in qian, even though you might write this dot in the corner as the last stroke, in Wubi we consider this red diagonal, or stroke 3, to be the final stroke. To sum up, to get the full code of any Offchart character with less than 4 roots, type out the roots and add a disambiguation code at the end. The disambiguation code procedure isn't too hard once you get used to it, but it can be a bit annoying to think about while typing. Luckily, most common characters you come across will have abbreviated codes. For example, xiang has the full code SHNU, with SHN for its roots and U being a disambiguation code. But by the time you've typed out SHN, your IME should already be giving you xiang as its first suggestion, and you can just press space without having to type the full code. That is, many of the most common characters have abbreviated codes, and you don't actually need to type out the disambiguation code unless your IME gives you the wrong suggestion after you've typed in all the roots. And that's how to type any single character. Here's that same information again, but in a flowchart. Up to this point, we've managed to find the full code for any single character. And this is already enough to type, but Wubi has more tricks up its sleeve. There's a lot more space left to assign codes to multi-character words. And it's not hard at all. As long as you know how to derive the full code for any character, you can also type these multi-character words. For 2-character words, type out the first 2 letters of each constituent character's full code. For example, Shima can be typed with W, F, T, C, and Idian can be typed with G, G, H, K. For 3-character words, type the first letter of the first 2 characters' full codes, and then the first 2 letters of the last character's full code. For example, Wei Shima can be typed with Y, W, T, C. Notice here that Wei actually has the shortcut code O. But the letter we took for Wei is actually Y. This is because we could only take letters from the character's full codes, not their shortcut codes. For 4-character words, type in the first letter of each of the character's full codes. For example, 千言万语 can be typed with T, Y, D, Y. For words longer than 4 characters, type out the first letter of the first 3 characters' full codes, and then skip all the way to the end and type the first letter of the last character's full code. For example, 此地无银300两 can be typed with H, F, F, G. And here's that same information except in a flowchart. Compound word input not only decreases the number of keystrokes required to type, but it also prevents you from having to think about disambiguation codes. Here's how many keystrokes it would take to type that sentence if you were only using full codes and single character entry. Here's how many keystrokes it would take if you only type single characters but allowed abbreviated and shortcut codes. And here's how many keystrokes it would take to type it with Wubi compound word codes. Just for fun too, here's how I type the sentence with Pinyin. I've tabulated the results down here. As you can see, Wubi word input is really fast, though Pinyin, to its credit, because of really good word prediction, is also really fast. I will say though, that with Pinyin, I was constantly having to make sure that the suggestions were actually the characters I wanted, and having to choose candidates really slowed me down compared to Wubi, even if the raw number of keystrokes is roughly the same. As you can probably tell, I quite like Wubi, but there are some flaws with it. Specifically with Wubi 86, there are some problems like codes being assigned based on non-standard stroke orders, but this is understandable since Wubi 86 was created before the current standards even existed. Wubi also uses some character shapes which are non-standard in simplified Chinese, which makes some codes pretty hard to figure out. Both of these problems are fixed in Wubi 98 and New Century, but again, this character is based on Wubi 86 because that's the one I learned before knowing about these problems. In general, Wubi also has some other problems, like shoddy support for traditional characters, and the fact that, despite the inventor's best efforts, there are occasionally still some code collisions, but these are often avoidable using word input or abbreviated codes. And I like Wubi despite all that because it's actually not too hard to learn. I went quite in depth into the rules in this video because it is useful to know, but when actually typing, I don't usually think about the decomposition rules. I just guess, and it usually works out. And I find it really interesting how many complex rules are needed to make something that feels so intuitive. Wubi is useful to me, largely as a way to type unknown characters. The speed advantage isn't particularly important to me, especially since Pinyin is also really fast nowadays, but there is a speed advantage even at my low proficiency level, just because I spend almost no time choosing candidate characters. But honestly, as someone whose language of daily discourse is English, Wubi is not a practical skill for me, and it's more like a weird hobby than anything else. Okay, bye.